welcome everybody. I'm here to talk about XenApp bare metal on Citrix Workspace Pod, or HP Moonshot as it's otherwise known. For those who don't know me, my name is Will Spellings. I'm an independent consultant working out in the UK. I help in the UK steering group, the user group in the UK. And I tweet and blog, so feel free to follow me and sign up to my blog posts and stuff. This presentation actually was supposed to have an accompanying series of blog posts talking about what I'm going to talk about today. Unfortunately, the client I'm doing this for got a bit upset that I was giving away too much, and they said, no, you can't put this up, please take it down. So unfortunately, you won't see them for a few months yet, but hopefully I do plan to get them online eventually. So who's heard of Citrix Workspace Pod? Hands up. Almost all of them. Who's heard of HP Moonshot? Yeah, most of them. Cool. It's going to be a friendly crowd, isn't it? So, bit of background as to what we're doing. Main objectives of the project, I think we're in general actually. We've got a very, very large VDI, 100,000 plus seat implementation, loads and loads of servers, costed a lot of money in storage, power, etc., etc. So a big drive for consolidation and reducing the number of servers, reducing the power, of course, and removing all the kind of storage and all kind of costs. Again, removing the power, removing the VTAX, so a lot of money is being spent on vSphere. They wanted to get rid of that if they could. Getting rid of the desktop. So again, a move to XenApp, move to more application-centric delivery. Everyone needs a GPU, okay? He's not here, so I thought I'd put his picture. Everyone needs a GPU, so obviously everyone doesn't need a GPU, but they wanted to be able to provide GPU for more and more applications that need to use them. These things are really, really expensive. Obviously they're great for serious CAD users. The ones on the right have got the Intel Xeon chipset using the Moonshot. They've got a GPU built into the die. So effectively you're getting free GPU in the service, which is nice. So everyone have a GPU. They didn't want to start building all this stuff. This is a provisioning server PVS infrastructure, for those who know. They don't have that today, and they didn't want to build it just to support this particular environment. It's going to be a big environment, it's going to be in lots of different data centers, lots of sites. That meant a lot more SQL servers and highly available provisioning servers, and so they just didn't want to have to start doing all this to do as part of the project. Another objective was a 1 hour build time. So they want to be able to deploy image updates and images within an hour, which is great if you have a provisioning server, but if you don't, then how do we do this? They want to be able to roll back, roll forward, etc., etc. So that was an interesting challenge. I'll cover briefly. So a bit introduction to the hardware for those of you, I think most of the things I'm going to go through quite quickly. This is what it looks like. It's basically a 4.5U chassis with 45 slots for servers, and you can plug one of, I think, about 8 different cartridges in there. So there's the VDI cartridge, there's the XenApp sort of cartridges, there's ARM cartridges if you want to do fancy web stuff. Quite a flexible system. There's two switches in the middle, and they feed out to I/O modules at the back for connecting to your switches. Oh look, there's the back. There you go. So that's the you've got 6 440 gig uplink. So there's oodles of bandwidth, fans, power supplies, etc. And then you've got the management module in the middle. Just got a Cat 5 for it. And a bit closer at what it looks like. Pretty picture. These are all hot swappable, so you can just literally pull them out. Everything else is running. Put a different one in, or put a replacement in. The switches are all hot swappable, so everything's hot swappable, which is great. So the cartridge that I'm going to focus on is the one that HP produced for XenApp workloads. These people, the M710, they still do them, but there's a slightly updated one called the P. I think it's Performance, I don't know what the P stands for. But anyway, it's basically a CPU revision, so it's got slightly later Intel Xeon than the 710. 4-core CPU, 8 with hyper-threading. The CPU rev has increased the frequency of that, so this is now almost 4 GHz in turbo mode. You've got 32 gig of ECC RAM on each one, and you've got an integrated GPU, which is great. Supported operating systems at the bottom. Again, this is XenApp workload, so we're interested in sort of 2012 R2, maybe 2008 R2. If if you want to be really retro. Power, typically about 50 watts a server, which is great. They can go up to 83, so if you're stressing the GPU and stressing the CPU, obviously both of those use quite a bit of power, so you can get about 83 watts.
When you say server, Neil, do you mean per card or per four?
Yes, this is per card. So this is the cartridge server that goes into it. So this is what you get in one of those chassis. So 4.5U. You can get 1.4 terabyte of RAM. You'll get 10 gig NICs, which are the internal ones. 40 gig QSFP uplinks. It's massive amounts of bandwidth you can get on this chassis. There's 2 independent switches, 45 GPUs, 45 CPUs, which correspond directly to the cartridges that are in there. So altogether 180 cores. Your local storage on each server, you can choose different, so you can choose like a single cartridge with either sort of 120 gig, 240 gig, 480 or a terabyte. So that all together in one chassis gives you up to 43 terabytes of fast SSD storage in just over 4 years, which is pretty cool. And around about 1,800 users. Remember, this is just one chassis. In less than 5 years, about 800 users. That's about 40 users a server there. So, stack these into a rack. I've been slightly optimistic my numbers getting 10. You probably wouldn't get 10 unless you have a really tall racks and very good power delivery. So say we get 10 in a rack. So that's in one rack. We've now got 450 GPUs, 450 CPUs, 3,600 cores with high threading. 430 terabytes of SSD storage, supporting roughly about 18,000 XenApp users in a single rack. So, it all sounds great so far. What's the catch? Well, these things are headless, right? There's no video output, there's no USB, there's no anything like that. They're literally slotting cartridges, which is tricky. So this means that there's 2 ways of doing it. There's an easy road and there's a hard road here. So we're going to start off with the easy way, obviously, which is we didn't do this. This is a recent.
This is why it's called learning.
Yeah. They've only recently built this easy path. So
Neil's on a day rate.
So the easy route is to buy one of these, right? So this is I think HP call them remote console administrator cards. So it is just another slot-in server card. And if you're familiar with HP, this gives you all these sort of ILO features that you might get in a normal HP box, right? So you can do remote console to a cartridge. You can do remote ISO, things like that. So it's great for getting your first image down. Obviously, the downside is that they can only connect to 4 cartridges that surround them. So if we put this in slot 23, for example, you could only connect it to the 4 surrounding cartridges. So it's really a sort of troubleshooting thing and to do your first image thing. It's not a generic, I can connect to any cartridge in the chassis. So it's quite a limited use case, but it does make your life easier because you can do things like mount an ISO to a cartridge, which is great if you're doing a Windows server build, right? The reason it can only connect to 4 is if you look how the backplane in a Moonshot system works, it's a toroid. So each kind of cartridge can connect to sort of in this kind of shape, and it's all kind of in a nice toroid. So that's why the PCI bus only gets exposed to the 4 surrounding cartridges. So that wasn't available. They only just released that. I'm not sure if you can actually buy it, but it's listed, but they might not actually buy it yet. But I've been testing one; it's quite useful. So we have to do the hard way, which means you'll need to do this.
Okay.
If anyone knows what that is, that's using Pixie Boot. Now,
I genuinely want to have a shower now.
Yeah, I'm not put gratuitous nudity in my slides. So I generally did Google for a pixie wearing boots. So I was looking for some nice guy with, boots.
That's how explain it to your missus.
So that's what I Googled for on Google Image Search, and that's what came up. It's basically, that's what Google says, so that's what I put it in, right? So
You justify it any way you like, mate.
exactly. So you need to know about this stuff. You need to understand how the PXE boot process works. You first use DHCP options. You need to understand the environment you're in. You need IP helpers on your routers, all that kind of stuff, which is complex, especially in big environments. And you've got different teams and all that kind of stuff. Getting this stuff onto DHCP scopes. So be aware of that. So we need to prepare a build environment. So this is kind of a checklist of stuff you're going to need, right? So you need some kind of PXE TFTP service to actually boot these cartridges against the network. Remember, we've got no remote screen or remote keyboard or anything like that. There's no ISO mount. Way of deploying the images down to them. So that can be WSSCM. We need the Windows ADK, which is Assessment and Deployment Toolkit. That used to be called the Windows Automated Installation Kit, a.k.a, but they've renamed it. You need the HP Moonshot OS deployment pack and the documentation. And it is a case of RTFM because there's loads of useful stuff in that document. This gives you the files that you'll need to stream into your Windows image to add drivers and stuff like that, and answer files and things. You'll need a Windows Server image itself with your XenApp software in it and whatever software you're going to put in your image. That could be Wim or VHD. I'll cover that a bit more detail soon. You'll need a boot Wim and an unattended.xml. So the boot Wim is the thing that initially boots up. You can get that off with Windows CD or source media. And unattended.xml is part of this deployment pack. So that's effectively does your unattended Windows build. Remember, there's no GUI, so there's no Linux X. It has to be completely unattended. And a control PC. So this is where you have your tools, your PuTTY, your web browser, that kind of stuff. So options for PXE and TFTP. You can have a Linux VM doing that. You could use an existing one if you've got other stuff that needs the PXE environment. A lot of places build their ESX servers by PXE, so you might be able to use them.
And did you try that like on a virtual environment first?
Yeah.
You know, that's the problem with the PXE. If something goes wrong, you never know until nothing gets deployed.
yeah. So it's always good to get all of this in a lab first to see what works and what doesn't work, and then migrate it out into the real world. But again, lab and real environments can be vastly different, right? So it's fraught with danger. Anything to do with PXE is like, I was a bit scared of it, you know, because it has impact on booting stuff. So. You can use the WDS, so Windows Deployment Services does include a PXE role, and that's just a role of Windows Server.
Did you get a picture of a PXE roll?
No?
Oh, no.
Sorry.
Not that he's going to show you.
I hope not.
Can help yourself. And there's third-party software which do this as well. So things like One Nomad and SCCM all have PXE options to TFTP. Plus, once you've chosen the one to use, obviously then you need to make them highly available. So you think about how you're going to load balancer, make them highly available. Things like UDP, it's all broadcast stuff, which is really hard to load balance and all kind of stuff. It's quite a complex area, so think about that as well.
Can we boot off ISO, or can you attach an ISO to a CD?
No. There's no ISO boot or ISO mount on any of the cartridges unless you have that special administrator cartridge, yeah? And then
So they don't even have a CD-ROM, they don't...
They have nothing. There's no hardware on the server chips themselves that can do any kind of thing. So it just boots, PXE boots, that's it. Give me an OSM. If there's nothing on the local SSD storage on the cartridge, then you're going to get nothing. So it's either PXE, local boot, that's your option. Sourcing your image. So you need to get an image down somewhere. So again, you can get this off the OS ISO source media in the sources folder. If you've got an existing image running on Hyper-V, you can export the VHD and use that. You can create a VHD from an NDT task sequence, so NDT supports creating a VHD at the end. And you can also use a WIM exported for an existing OS. So effectively you do a reverse image like you would in PBS. So you take an existing running OS, then you create the WIM by running the Disney ImageX tools on it.
Did HP give you an option of pre-shipping it with image on?
They would do, yeah. If you're big enough customer, then they would put an image on for you. Another option I saw that server, the new server 2016 stuff is being supplied as a WIM, which is great. That means you don't have to do anything. So that'll be nice when that comes out. So prepare your boot and image WIMs. So first is enable EMS. I'm hoping no one knows what EMS is because I'm going to explain it a bit. Add the Mellanox drivers. 2008 R2 has the support for Mellanox built in. If you're in 2008 or 2012, you'll need to add those drivers into the image. Again, HP give you the tools to do this. Then we need to add the modified image to WGS database. So I'm using WGS for the sake of this. Save Pixie, so in WGS, I don't want WGS to start responding to anything other than my own cartridges. So I think it's good practice just to say respond only to known client computers. And you're not accidentally going to build anything else. So only Pixie with things that are in its own database. It's a pretty good place to start. So in the image that you've been updating to WGS, you need to enable an attender mode. Don't do that, it's going to boot up and give you a nice GUI saying, yeah, I'm installed Windows, and obviously there's no keyboard and mouse or screen, so you're not going to know what's going on, nothing will happen. So you tick that and then put the unattended.xml, which HP give you, edit it first, because it's got things like passwords and stuff in it you need to put in. So then get this stuff into WGS. Various ways of doing this, you can use a GUI, you're old school. Just a wizard, add MAC address. There's a PowerShell commandlet. You can use new WGS client to add it in there. HP, again, this HP deployment pack, there's a nice called add HP Moonshot nodes in WGS, all in one commandlet. And that will actually talk to the chassis manager, read all the MAC addresses from the chassis, talk to WGS, and add them all into your WGS database. Obviously, giving it all your credentials to do all this. All in one kind of function, which is quite cool. Again, this is what it looks like record into WGS. Got your device ID, which is the MAC address, and the name. You give it an initial boot image. Now this one is it's called COM1. The idea of that is that the output from the initial boot goes to COM1, because remember we've got no video, we've got no GUI, so we want to get an output out of the serial port. So we can connect to these via the serial port, that's all your output you get. Give it the boot image, so again this can be off your Windows media CD. So we've built our build environment, we've got our image on there, we now have to build our first cartridge. So set it to Pixie boot. There's two ways of doing this. You can set it to Pixie boot once. What that will do is the first time it boots up, it will Pixie boot, and then from then on it will always do local boot. And that's great for actual build, right? Because you want to go in the build loop. You set it to Pixie, you set always to boot into Pixie, and then it'll always build every time it boots, which is probably not what you want. There's a boot once option, which is quite cool. And then you can do the power control. Again, via the web GUI, the chassis manager, or you can SSH into the chassis manager and issue the command set node power on. And then that particular cartridge will then power on and boot up. And then if you SSH into the chassis manager, you can connect to the serial port on that cartridge, and you'll see something like that. So you can see the BIOS screen as it boots. From Pixie boot, so get an IP address from DHCP, download the code from your WGS server or whatever TFTP server you're using. Download the boot.wim, and then you see this, and that's as far as you get. So this is the what's called SAC. It's part of EMS, so Emergency Management Services. So I never knew Windows had this kind of secret terminal serial port management console, right? It's like Linux. It's like, oh, that's fantastic, right? So this is in 2008 R2. It's in 2012 R2. It's disabled by default, so you have to enable it using those BCD edit commands earlier. And once you do enable it, you can do stuff via the serial port to Windows Server, which is kind of useful because the serial port is the only way of connecting to these servers we've got at the moment. So you get what they call these channels. So if you're going through a Windows build, you'll get what is called setup channels, which is the WinPE part of the build. And you do a kind of control tab to switch between channels, and then you get sort of debug output. In the SSD console, you have some quite useful commands. So you can start the command prompt. You can dump the kernel log. You can display the networking stuff. So you can display the IP address. You can kill processors. You can restart the system, shut down the system, do a crash tip. So there's some quite useful tools you can do in this. Again, kind of old school. We have to remember stuff that you can have because again, there's no doing. You've got an ODP, and it's like, oh, you're still building the server, right? So this is the kind of output you'll get as part of the WinPE build process. You can see it scanning through the local file systems and provisioning the local storage. Once you have a OS up and running, so it goes through, does a sysprep, reboots, and hopefully you've got a running server by this time. If not, then you stop troubleshooting. If you started off with a native 2012 image, RDP is not enabled by default, which is kind of a chicken and egg thing. It's like, okay, I've got a running server, but I just can't RDP to it to do anything with. Not a problem if you've migrated the image off Hyper-V, because obviously you can enable RDP before you do that. But if you start with a completely native image, then you will need to, in your command prompt, obviously just enable the firewall to let RDP through, and then turn on the terminal server RDP administration. So, we've got a running OS. We now only capture this back to WDS. There's a process called reverse capture in WDS. It's like a wizard you run through. It's a bit much like the PBS reverse image process. It will basically suck an image back to the WDS server. So it reboots, goes back into MPE. There's a special switch in the unattend that tells it it's in reverse image mode, and then it sucks the image back to the WDS server. Obviously, standard sysprep generalize stuff first to remove any sort of uniqueness in the image. So now we've got our image on WDS, we can now hopefully deploy to the rest of the chassis. So this is an example of unicasting. So I did a unicast to 10 cartridges at once. So this scale on the left is gigabytes per second. So it times up by 8 to get this kind of gigabits per second. So you're looking at around about, let's see on there, about 2.5 gigabits per second. So if you've got a 1 gig network, you'll saturate it by just building 10 cartridges at once. I then decided to build an entire chassis using unicast because I'm a bit mad. ESX teams were going to go mental when they saw this graph because I basically maxed out a 10 gig network on one of their shared hosts. So this is building 45 servers at the same time, and that peaks at 8 gigabits per second. So we maxed out a 10 gig network. But it's 1 gigabyte per second, so about just about 2 gigabits per second. Obviously, you can multicast, which is preferable, right? Because you don't want to send, if you're building the same image to all those cartridges, and you just want to send it once, and the same image goes everywhere. So WDS, you can do multicast, and then this is a screenshot of multicasting the same image to lots of cartridges at the same time. It's actually quite smart. If a cartridge wasn't there at the start of the image, it kind of just starts halfway through, and then it tells WDS, so, well, I didn't get the first bit, can you send that again? And it just loops back and sends it. So it's actually, it's one of those old tape reels that just keep going round and round and replaying the image through. It's a bit like that, really. And it just keeps sending the same image out until everybody's got it. You do need to tune WDS. There's about half a dozen registry keys to get the best throughput, because the defaults aren't really optimal, so you need to do some tuning on the WDS server to hit the maximum. Again, things like you need to be aware of IGMP, so if you want to get the best performance, you need to make sure IGMP is enabled on the switches, so that only the ports that need to receive the multi-best traffic get it, so you're not sort of splashing it around your network unnecessarily, because otherwise people will start moaning. So, how does this perform? Pretty good, actually. Very good. So this is the longest standard login VSI test. CPU utilization on the left, the time of the test there. So this is about 30 sessions, that's about 45 sessions. This is the average, this is the medium workload, so you're not doing a lot of GPU stuff here. So yeah, VSI max is at 50 sessions. Oh yeah, pretty good. And because it's bare metal, there's no hypervisor there, so you get really snappy. User experience is really good. Again, local SSD storage, so very predictable in terms of file system performance as well. This is the rich application workload. So again, this has got some GPU stuff in it. So I think the VSI max is around 42 sessions for that, which is not bad for a little old 50 watt cartridge. This is the power consumption during the test. So again, maxes out. This is the M710 and the M7P, so the P will be slightly higher. But again, you can see it maxes out around about 2 watts. That's the one with the GPU. The rich application workload, again, maxes out around about 65 watts. And about 50 sessions. So pretty good scalability. Integration, so once we've got our Moonshot chassis, how do we connect them to the other stuff? Well, there is a connector for XenApp and desktop, 7.6 or 7.5. Download links on a Citrix blog post somewhere, but I'll currently do kind of a shortcut to that if you want to download it, because the URL is just massive and complicated. So it's not an official, again, it's not like an official, it is by Citrix, but they say, well, it's unsupported, so use at your own risk. But it does have the connection type in here of Machine Manager. You give it the chassis manager details here, so the IP address, your credentials. That will allow you to do things like power control from within Studio. So you can restart, shut down cartridges within Studio, which will then talk to chassis manager and say, shut down that cartridge, which will then call the...
Could you go back one slide?
Sure.
You mentioned the connection using the Moonshot Machine Manager. Was
Yes.
that supported by Citrix?
The plugin to give you this connection is unsupported.
Ah,
So if
okay.
you had a problem with it, they would say, well, it's a tool to help you out, we're not going to officially support it.
Okay, but the connection itself is supported. Because if you're working for a major insurance company or a bank,
Yeah.
which you're mentioning, which are buying multi-million-dollar appliances, the lacking of support of that connection, isn't that an issue?
Not really, because to be honest, it's a nice to have, just to give you the power control in here.
Okay, that's
Actually, they're probably not going to use this at all, and they're probably even not going to use this plugin, because they're going to use some other kind of high level automation to drive all this. So Cloud Platform is having official support added for Moonshot. So that again, you'll be able to provision Moonshot bare metal VMs, no, bare metal servers in your chassis from Cloud Platform. And again, the chassis manager has a RESTful API, so there's no reason why any third party can add integration that one as well. So, summary, what do you need to know? Know your Pixie, know the serial administration console, because if your first build doesn't work, then you're going to need to delve into that console to find out what's going on. Image management, so again, having ways to deploy images quickly, Windows deployment services. You need ways of getting that image out to multiple Windows deployment services, and you need to make them highly available. Multicast, so if you don't want to saturate your network from your Windows deployment services, you need multicast in the mix, and again, you need the IGP stuff, which probably needs to talk to your network guys to make sure that it's enabled on all the switches and the right version, etc., etc. A lot of networking stuff, I did quite a lot of work because the Moonshot chassis have got Comware HP switches in, and normally you're plugging them into a Cisco switch in most places. So again, it's like, where's the demarcation? You're going to do layer 2, you're going to do layer 3, where's the routing going to go? It's going to go on the HP box, it's going to go on the parent Cisco box. So lots of kind of networking decisions. How are you physically going to patch them? You're going to have sort of cross-wired and use LAP bonding, all that kind of stuff. So there's a fair amount of networky design stuff to get them in a highly available manner. And with that, I'm finished. So any questions? Yes, sir.
Hello. Is that true Workspace Pod? Because when we saw Workspace Pod at Summit, they ruined it by putting Hyper-V and then the HP Storage Works unit and Melio in. And I thought
This isn't the official
so this is basically
Workspace Pod.
Right.
Workspace Pod uses the same hardware. So it uses the HP
I
stuff.
just wondered.
No, yeah,
Right,
because the Workspace Pod stuff, you've got PVS in there and stuff like that. So this is the same hardware, but completely different
So
design.
we had very similar experiences. We have one customer who's running Moonshot but with no broker, so they're just doing direct, and it's the 4 nodes, 4 PCs per cartridge, so it's
Right.
desktop, your two
Then desktop nodes, yeah.
And what
700s.
what we found was SCCM really was kind of the way to go about managing these things, because it is basically PCs in a data center at the end of the day. But the XenApp workloads, we're just starting to do some testing now, and it's brilliant. It's just absolutely the way you should do stuff.
Yeah.
Because you get rid of all that virtualization crap, which makes it cheaper from a support perspective. 30 users a box, I know it feels a bit old school these days, but I still dislike, you know, hundreds of users per server, so if you do get the occasional blue screen, it's sensible.
Yeah.
And you just
More servers,
Yeah.
manageable number of users per box.
Yeah, and I think still, because you're still getting that 4-bit U rack, it's,
Density's great,
Yeah,
access is good, and you get the GPU for free, so
yeah,
it's a win-win.
absolutely.
What would you say the kind of ceiling is for number of users? Because this obviously appeals to large enterprise, right? Because of the density of users. So there must be a ceiling below which it doesn't make cost-effective sense to do it. So what kind of number of users would typically fill up on
Obviously enough, we're actually internally looking at that map right now. I don't know if I'll be allowed to share it once it's done, or whether we're going to treat it as IP.
Oh, you can buy the chassis like with like one cartridge, I guess.
Yeah, but you
You
wouldn't.
should have started.
Oh, I understand.
Yeah,
I mean,
if you're going to do it, you want them fully populated.
You want to fill it up.
Yeah.
Yeah, absolutely. But then again, some of the rollouts that we've done, where you've gone great big Cisco UCS, which you know millions, and then you start doing your 18-month project rollout, and you've got 300-400 users on. With this, you buy a fully populated Moonshot cartridge, you get that amount of users going, then you buy another one and you keep. So VDI deploys, you know, you don't get them done in 6 months, do you? How long we've been on? Years. And if we
Don't mention the customer name.
absolutely.
Again, you can buy a chassis and say fill it with like 15 cartridges,
Yeah,
right?
yeah.
And just leave the rest blank, and then you know,
Yeah.
if HP come along with an updated cartridge, then you know you could just fill it with the newer
Yeah,
the new model, right? And then unplug the old ones and just keep doing a rolling network.
It is, and the way that I think HP are pitching it in terms of, I know you mentioned stuff like the video art's not there and stuff like that, it's kind of HP aren't targeting it like that. They're basically saying this is designed for a bulk, so it's designed for getting it built is a pain, but once it's going, that's all it's ever going to do. So you wouldn't use that cartridge for much else, other kind of workloads.
Yeah,
It's
it's got different workload. You buy a different cartridge for it, right?
Yeah, it's like the opposite end of having a generic DL360 style server. It's really targeted workloads, but everything I've seen I think is fantastic with it.
and what was the logic like behind not using PVS?
Yeah.
Because the main concern I see here is I update an app or I remove
They
an
did,
app.
the,
No
the, the,
regression
biggest,
test.
the biggest requirement for not putting in PBS was no runtime dependency on additional infrastructure.
I understand, but you know, if you remove one app and you don't do regression testing, you break the whole chassis in one shot.
Well,
Or
I
you
mean,
recover them.
Yeah, and you can still get an image down to it in like less than an hour, right? So, you know, in terms of your rolling upgrade, you know, you upgrade 50% of your cartridges
I
one weekend,
understand, but
and you do the other half next
You
week.
could also
an hour
install
of downtime.
PVS on one of the cartridges.
I don't think Neil saying that you shouldn't run PBS on this. I just think it was just
Yeah.
a requirement.
That's a requirement. What was
Yeah.
they didn't want to start building
Yeah.
new PBS servers with SQL databases and making the databases highly available and making PBS highly available and introducing additional infrastructure just to get PBS in there, right? And so like, well, you know, we just want to build the image. Once the image is down the cartridge, it's just going to run. It's not going to be dependent on anything else apart from the actual physical network connectivity, right?
Or still, there's the PXC, there's the TFTP that you have to.
But they're not runtime requirements, right? So PBS is to keep my server going, the PBS server has to be there as well, right? Obviously, yes, you do need the stuff to build the cartridges, but you know, if that stuff fails, okay, we just don't need builds, right, until it's fixed. So it was the runtime dependencies that they didn't want to introduce. That was a big thing. Any more questions? I think some cold beers waiting outside, so there you go. Thank you very much.